Okay, new project. I've decided I want to make myself a fly cutter. I haven't got a fly cutter. They don't seem to be overly readily available. It's not like you're tripping over them. So I've decided to make it so it's going to fit in an ER32 collar. And I'm going to use the biggest collet that I've got. And that is a 20mm. So I've decided around about 105mm long. I've got some 4140 bar here in the bandsaw ready to go, and I've got my little spray mister all set up. Tank over here just chilling out on the leg of the hydraulic press. So that's a good thing about having the movable magnet. And I've got the magnet sitting down there onto the chip tray, I suppose you call it, of the bandsaw. The magnet's on, but it's probably stand there by itself. Right, let's get this party started. So I've got my bar stock here cut approximate length. Now I'm going to put it in the milling machine and put a angle on the bottom of it to accept the high-speed steel that's going to go in there. There's usually have an angle, from what I've done in my research, from between 15 and 25 degrees. Now, will I go with this 1/2 inch? I mean, I don't have any 3/8 high-speed steel. It's possibly a little bit overkill. 3/8 might be better. Anyway, so I was thinking I could put this in I've got a dividing head. I've got a semi-universal dividing head. And I could put this in that and set the chuck up, kicked off at 15 to 25 degrees in the chuck. But I thought that'd be too easy. Let's do something a little bit different and play with our gauge blocks. So, gauge blocks, for people who don't know, are very accurately machined little blocks, oddly enough, that have accurate widths to them, and they're used for accurate measurements. Now, also to do angles, you can use a thing called a sine bar, which is this guy here. And how a sine bar is used is if you want a particular angle, then you find out the sine of the angle, and then whatever that distance is from there to there, according to the calculation, is the size of the block stack that you need to put under there. So for instance, if it just so happened that the angle requires a 50mm sine block, then effectively that would sit under there like that. Now that's sitting on a rubber mat, really not ideal. It's probably going to fall down if I'm not careful. So as you go up higher, obviously the angles change, and lower, so forth. I mean, that was a redundant statement, but you get the idea. So this needs to be in the vise held at around about 15 to 25 degrees. I know I keep saying 15 to 25. I was going for 15, but unfortunately the way this sine bar is made, in this application it tops out and hits the tail down here too soon, so it ends up lifting up the little round bar that's down the bottom. Now yes, you can turn it around that way, and which I will. Even still, the problem with doing that, okay, that's 90 degrees, well you'd use a square, you don't use a sine bar, but anywhere much off 90, you can't pick up the bottom tangent, I suppose you'll call it, of the round bar. The block has to sit on the round bar. So if it's too tall, it can't sit on the round bar in the perpendicular position. So I've done some mucking around, and I've come up with a 20 degrees is as good as I can get. Now, as this stands up here, this isn't 20 degrees. It's 20 degrees in this area, but we're in this area in measurement, so it's the other 20 degrees. So that's 90, we need to come back 20 degrees off 90, so we're looking for 70. So if we get our calculator out, which I am using a phone at this point in time, which I always put it somewhere else, we go sine 70 degrees equals 93.969. However long your sine bar is, whatever it's designed to be, is what you would put in this next figure. If it's imperial, you'd use your imperial numbers. This is metric. This is a 100mm sine bar. So we'll times that by 100. Now we have 93.969 and so forth is how high the blocks need to be to produce this sine bar at 70 degrees, which will be 20 degrees off 90. So to make that, we need to come up with some blocks. Here's my little gauge blocks. Now some of them have still got a little pink fuzz, or the little pink covering on them. I'm holding on to keeping them in as long as I can, because I live in quite a corrosive environment as far as rust and that goes. So I'll try to keep them wrapped where I can. So we need to make a stack of blocks 93.69 tall. We need a block to start with that ends in 0.09. And we do have on the end here, this guy here, it's 1.09. So we minus 1.09. Now we end up needing to have another 92.6 left. So to get rid of the 0.6, we need something that ends in 0.6. 1.6 minus 1.6. Now we need 91 left. Now it's relatively easy. We need something that ends in 1. There's a 1 mil block. So, in minus the 1, this is painfully obvious now. Now we need to get 90. Well, there's a 50, a 30, and a 10. 50, 60, 70, 80, 90. Minus 90 is, guess what? 0. So now I've got my little block set. I'll move that out of the way. These are the blocks that are required. Now let's unwrap these guys. This one's been played with before, but I'd say the other one hasn't. Rust on these things would be devastating. It would just stuff them up. Let's put them together. Now, this is called ringing. These things are so flat that they'll stick together. It's pretty cool when you look at it like that. Okay, so we've got 80 together. Let's put another 10 on top. Now while I'm rubbing it on my hands, it's supposed to make sure there isn't any dust and stuff on there, but I reckon it's got something to do with, everyone's got a little bit of grease, a little bit of human oils, and I reckon it helps it to ring together. I'm probably totally wrong on this. Okay, rightio. So, we've got our little block set together. Now, they should be pretty accurate. This is a gauge grade 1 set. You can get grade 0 and I think 00. What was our total we had to have? I think it was, what was it, 93.69? Let's grab our calipers. If only I could find them. And ever so gently, you do not want to mark these things. It's probably not even advisable to do it, but 93.69. So that could be showing two things. These gauge blocks pretty good, and this caliper's pretty good for a caliper. Anyway, let's move over to the milling table. This is the setup that I've gone with. I've got the job is sitting in 2 V blocks. I've got the job also sitting on a parallel, but parallel used in the wrong way, round. Normally they go edge on, not an ideal way because there is possible bit of bow or flex in that direction. But my vise isn't flat bottomed, so it makes it difficult to offer up the old sine bar down in the hole of a vise. So that's what I've sort of come up with. Here's my little gauge block stack. So ordinarily your sine bar would go this way, and that's what the relief in the back for, is so that it doesn't get in the way. But because we're going really close to vertical, it doesn't work out. So we're going to spin this guy around, push the gauge block, the sine bar just so it's touching the job. And the reason why I have this very top one sneaking out a little bit, that is to make sure that he's getting in underneath that perpendicular spot on that round bar. Right. So that's our little setup, which will be 20 degrees off 90. So it's actually 70, sitting upright 70. So we can see we're a little bit off there. Now if I gently apply a little bit more pressure to the vise, just bump this over, because I've got to bump the vise off, it's holding a bit too strong. Bump this over until just before it kisses, and we'll check. I think this can go in a bit further. Bottom. What are we looking at here? Let's take that away. Okay, so we've probably gone a little bit too far, if anything. So let's just loosen that off and straighten it up a bit. Back away. So I can see light shining through, but the light gap at the bottom and at the top is exactly the same. So that's got to be really close to 20 degrees. For this job, doesn't matter a hell what the degrees is, but it's good to play with your toys. Okay, so tighten the vise up. Take out our little setup. Now we'll deck that off, and that'll give us our 20 degrees.